Hello everyone, welcome to this video. My name is Wycliffe, and in this one I want to share with you how you can monitor the health of your experimental plots using Google Earth Engine in R. So we'll start by loading the necessary libraries, including the rgee, which will enable us to use the Google Earth Engine servers to also to access data in the Google Earth Engine data catalog. We'll also need map edit, which will enable us to draw our experimental plots. And then we will also need dplyr for some simple data wrangling. As usual, we start by initializing our rgee session, and then we draw our T fields. Let's say your experimental plots are T fields. So we'll start by drawing features. After drawing features, we will label them. Sometimes you already have your shapefiles of your experimental plots, or whether they are fields or just experimental plots, and you've labeled them as maybe field 1. You also have field 2. Then we'll just do 3 fields or 4. Field 4. You can use fields or you can use plots, it doesn't matter. After that, we will only select that field, which is field ID. Sometimes when we create feature collections, additional columns are added, but we are only interested in one, okay? So we get this interactive map where we can draw our experimental plots boundaries. I have no idea where your fields are, but let's say one of the plots is here. So it's located in this field. So we capture that. Maybe that is field 1, and then field 2 is somewhere here, and then field 3. Of course, your fields would have the same unit or same size, and then your field 4 is maybe somewhere here. They will have the same size in most cases. So you will have the shapefile of your fields. Okay, so after doing that, we will have what we call a Google Earth Engine feature collection, a Google Earth Engine object feature collection. So if you look at T fields, it's an Earth Engine object, which is a feature collection. This we can then use to filter our images and get health or monitor the health of the plots over time, okay? Well, so after that, we can get the Sentinel-2 image, which is an Earth Engine image collection. And from collection, we get a dataset. And from dataset, we look for S2SR Copernicus. So that is the satellite image we are going to use. And this image is compromised by cloud cover. So we need a cloud masking image collection, which is called cloud score. So we also get it from dataset. And then when we start typing cloud score, it pops up. Okay. So this is the image collection that has a band, which links with Sentinel-2, and we can use it to mask out cloudy pixels. So let's say we want to monitor cloud, not really the health of our tea plants for the month of October. So we'll have start date 2024, October 1st, and end date, that is the end of image acquisition, will be 2020, even 2025. Why are we talking of 2024? 2025, and then November 1st exclusive. So it will only capture the month of October. So to get the oct health or October NDVI of our image collection, it will take our Sentinel-2 image, and and then we filter bounds with our region of interest. So filter bounds with our region of interest, which is the T fields. After that, we'll filter date. So to filter date, we will take the start date from start date to end date. Okay, so that is the period of which we want all images that were collected over our region of interest, which is over the T fields. Okay, then to do away with the clouds, we'll need to link our cloud score band or the image collection with this, and then we map over our images. And here we use a function which takes image from our Sentinel-2 images and then identifies the quality assessment band, which is called CS, in the collection. And then, and then after taking the CS band, then our image will be the original image, but we update mask with the QA where its value is greater than 0.6. After that, we then create the normalized difference index, which is basically the NDVI, and NDVI is given by near infrared, which is band 8, and red band, which is band 4. And then once it is calculated, we can rename it as NDVI. Okay, so once that is done, we can get the median for that October period. Well, that is okay. Once we have the median for our period of time, then we can visualize it if you want. For example, map center object, and then the Earth Engine object is our T fields, and then the zoom level is maybe 15. Then we can add the layers, and the layer we want to add is latest NDVI, the October NDVI, and then we can decide to clip it to our region of interest. Actually, we could have even clipped it up here. So we can add clip to T fields. Okay, so here it's just October NDVI. And then, of course, that's the Earth Engine object. And then we add the visualization parameters, which we pass as a list with a minimum value of say 0 and a maximum value of say 1 and a palette of say low values red, middle values yellow, and very, very high values dark green. Okay, so we can visualize that. And now we see the normalized difference index for each of our plots. Okay, so after visualizing this, we can reduce region. Actually, by seeing them like this, it's not easy to tell which is healthier and which is not healthier. They all look quite green. The NDVI look quite good, but we can extract the actual means mean NDVI values for each of these. So we can call it mean NDVI statistics, and that is from the October NDVI. We can reduce regions. We reduce regions, and the reducer, the collection, first of all, is T fields, and then the reducer is a mean. So we get the mean NDVI over the space. that is over each experimental plot. And we do this at the native scale of the images of Sentinel-2 image, which is 10. Okay, so once we have that, we can pass it to as an SF object. So data SF, we use Earth Engine as SF, and then we pass mean NDVI. So that will convert the mean NDVI into simple features, and it's now available locally in our R session. So you can see the NDVI, and the mean here is the NDVI and the field ID. So for each field, we have a single number telling us the health of that plot. Okay, so you can decide to convert this to a regular data frame. So our DF will be data SF, and then we use SF package to drop the geometry, and then we can only select, let's look at it again. We can only select field ID and mean. Of course, that is those are what are left. So we can directly arrange in descending order of mean. Okay. So if we look at DF, we now see the health of each of our T fields, starting from the healthiest, which was field number 3, to the least healthy, which is field number 1. Of course, generally they were all healthy, but in your case, if you are concerned about your experimental plots and you don't visit them regularly, then you can remotely tell how healthy they are by looking at their NDVI over a period of time when you could not go to the field. So no excuse that you could not afford to travel to the field during that period. You can still monitor them from the comfort of your home. And you don't have to, it doesn't have to be tea. You can do this for coffee. You can do this for beans. You can do this for any other crop in the field that you want to monitor. Thank you. I will leave the script or link to this script in the description section of this video. Feel free to grab it from my GitHub repository and reproduce it with your own work. And remember to cite all the data sources you use, like this CS Plus, as well as the Sentinel-2 image, and also recognize the effort of those who created these packages you use in your work. Thank you and happy coding. Bye-bye.